Hello, my name is Tejeswar Rao and I am a student of Alma Better's November cohort, and this is my first module's Capstone project, which includes 20 coding challenges, and we have to provide solutions for that. It is divided into three sections. The code bug fixing has 5 questions, and the improvised perspective, where we have to improvise the code given to us, also includes 5 questions, and the final 10 logic building includes 10 questions for which we have to provide our own logic. So let us continue. So for the code bug fixing, the first one is we have to calculate the BMI, and the BMI function actually takes two parameters, weight and height. So we have to calculate the BMI based on this formula that is given to us. And the criteria is, if the BMI is less than 18.5, we have to classify as underweight. If it is greater than 18.5 and less than 24.9, we have to call that person normal weight. And if BMI is greater than 25 and less than 29.9, we have to classify as overweight. And anything above 29.9, that person has to be called as obese. Okay. So we have the criteria here. Now the problem with the code is, if we walk through the code, here we have a function, here is a formula, and here we are calculating the BMI. We are checking if the BMI is less than the value that is given to us. So if the person is less than 18.5, that person is underweight. Okay, that is correct. Now we have the next else if condition. If the BMI is greater than or equal to 18.5 or less than 24.9. Now the problem here is, we are calculating for the BMI if it is greater than 18.5 but less than 24.9, and here is an or operator. So what we are doing is, we are not creating a right boundary. We only have our left boundary, which is greater than 18.5. So what will happen is, suppose the BMI turns out to be 25 or even 26, it will still return normal weight because we have used the or operator. And what will happen is, any value greater than 18.5 will be turned as normal weight. So that is a bug which we have to rectify. And similarly for this section, for the overweight, anything greater than 25 has to be overweight. But since this condition precedes, what will happen is, any value greater than 18.5 will be normal weight. So this is a bug which we are fixing. So we are using our AND operator for both these things. And another crucial bug is, what we here have is, here we have 24.9 exclusive but 25 inclusive. So if the person, suppose the BMI index comes out to be 24.9. Now what we are using is here less than 24.9 but greater than equals to 25. So the value between 24.9 and 25 is missing. So for that particular value, what will be returned is obese. So that is also solved in here. Now what we are doing is, we are returning greater than equals to 24.9 and less than 29.9. So by doing so, we are calculating it properly and we are returning proper classification for that person. So this was the first bug fix issue. What we are also doing is math.absolute method of JavaScript, and by using this we are getting the absolute values without any problems for negative signs. So we are getting the proper value. So that's a validation check. And for the convert temperature also, we had a bug here. We had to convert the temperature and we will be given two parameters again, temperature and a unit. And if the unit is C, we have to calculate to Fahrenheit. So this is what we are given. Now if you look at the code, constant Fahrenheit is temperature into 9 modulus 5. Now the formula for calculating is 9 divided by 5. This is the formula. So the formula here written is wrong. Similarly, for calculating the Celsius temperature also, we have 5 modulus 9. Now this operator actually gives us the remainder. It does not divide but gives us the remainder. So this is also a bug which we have fixed in here. We have used the division operator. What we have also done, yes, so that's it. We are just doing it. Yes, this one. We have added a validation, and that validation is if a person enters, if some person writes or tests it, and if in the units he writes instead of uppercase lowercase, so in that case what will be used is invalid unit. Okay, it will be used invalid unit. So the problem is, if that person, even if he writes properly but in lowercase, what will happen is, since we are checking for the capital C and capital F, it will still return him invalid unit. So that is an unwanted thing. So in order to make things sure, what we have also added is we change all the inputs, the valid inputs, that is C and F, if by mistake or ignorantly if a person types lowercase, we are converting it to uppercase so that our function runs properly and returns the temperatures in Fahrenheit and Celsius as per the need. So here is how we have solved this second one also. Similarly, all other bugs have been solved, and if we come to the next section, improvised perspective, let us look at this case. Let us look at this problem, title case, and we are supposed to give another alternate solution for this. We have to write a function called title case which accepts a string as input and transforms it into title case. Now title case is each and every letter of a new word has to be capitalized. Now that is a title case. This is the input, and we have to convert all the first letter of each and every word into uppercase. So this is the title case. This is the title case output that we have to return. Now what here used is the function, when it receives an input, the words are actually first split. They are transformed into lowercase and they are split. So what we will have is, because we have a space here, what this function will do is it actually split it by spaces. So that is done. So after that we are looping through the array because it returns an array, and the words, what we are doing is, for the first word in the array, the first letter that we are capturing with this, we're accessing the array, and then we are converting it to uppercase, and then we are joining it with the substring method from the first index. After we have converted the first one, from the first, including the first, we are creating a substring which we are adding along with this. So then we are joining it and returning it. Now we are given a challenge to write it in map method. Now let us return to our code. Here our gist. So here what you're doing is, instead of this for loop, we will be using our map method. So what we are doing is, we are capturing this new array in this new sentence variable, and then the words are this input, this sentence is actually converted to lowercase first, and then we are splitting it by spaces. So after that we are looping through the words array which we created, and then we are mapping, and each and every word, and since map returns a new array, we are storing it in new sentence, and each and every word we are using this word.characterAt method, and what we're doing is, the first character of this word, the first character of each and every word which we are now accessing through this maps word, what we are doing is, the first character is transformed to uppercase, and then we are creating a copy. Slice returns a copy. So we are slicing from the first index, which is an alternate method to substring. So we can also use slice. So this word that we have, we are slicing from the first index, and we are joining the first character which was transformed to uppercase. Then we are returning this new sentence, and then we are again joining it back by spaces. So now we are returning a combined array again. So this method actually returns an array after joining it, and we are here now returning our title case solution. So this is the alternate case provided. Now for the logic building section, the code which we had to write on our own, when we come the logic building section. So let us reach the first, which one is prime numbers. So we have to come to the prime numbers. Now a prime number we have to find. We are given a positive integer as input, and we have to return an array of prime numbers less than or equal to n. Now we are given an input 20. Now we have to return all the prime numbers less than 20, and we have also to exclude 1 from the resulting array. So we actually can do it in this way. So when we are given this question to find the primes, what is the first thing that we can think of is, first thing is, we have to walk through from 2 to 19 and check whether each of these elements, whether they are prime or not. So for doing that, what we will do is, we will first validate what we have been given to do. So this is an edge case. We have to exclude it. We have to exclude 1 from the array. So this is an edge case. If a person enters 1, what will we have to return? We will have to return invalid input. Now if the input is greater than 2, we will automatically go through these checkup steps and will return whether it is a prime or not. So since the criteria is, we have to walk through each and every number until the input number is reached, and we have to check whether it is a prime or not. Now in order to check whether these individual numbers are prime or not, I have to do a check for each and every individual element. So for that we have this function here, or this code block here. So what we are doing is, let I is equal to 2, we are starting from 2, and I is less than equals to n, I plus plus. This is the outer loop which we will use to traverse till we reach the input element n. So until we reach that element, including that number, we will iterate. So this outer loop is for iterating through till the input number, and this inner block will check whether it is prime or not. Now in order to check a prime or not, the criteria is a number has to either be divisible by 1 or itself. So mathematically we can use a optimization, a code, an arithmetic property, that is, for a number to check whether it is prime or not, we need not check until that number, since we have to check whether that any number that is divisible until it reaches itself. For example, in order to check whether 17 is a prime number or not, we need not go from 2 until 17 to check whether it is prime number or not. There is a property in mathematics that if the root over of this number 17, until that, if we can check for divisors of 17, we can check for whether it is a prime or not. If any number until square root of 17 is reached divides 17, then 17 will not be a prime number. So instead of writing j is less than equal to root over of I, we can reverse the property by writing, when we square both sides, we can do the same. J to the power j, that is j square, is less than equals to I, which is equivalent to j is less than equals to root over of I. So we only need to check until that if the current number is divisible by the divisors which we are checking for until we reach the either square of this number, or we can say root over of I. If we check that if there is any divisor found, we will, this flag that we have used initially, whether it is prime or not, initially we are assuming that the number is prime, but if we find a divisor, we are updating the is prime flag to false. And what we are doing is, here is an optimization, we break early instead of continuing till the end. If we find a early divisor, we will break from this loop. So in this manner we can exit this loop and we can check whether it is prime or not. After this code block is passed, we will check if it is prime, then this result array that we have created, we will push into it. By this way we go until we reach the nth element or the input element, and we will check for divisors only until the root over of the input number. So by doing so, we can check whether it is a prime or not. Now as for the time complexity, the first thing is, we are using an outer loop, so it will run for n times. The inner loop will run for I times, that we have here, I times. Now we can actually say this I is actually this input. Now I runs for nth time. Now we can also say that since we are using j square is less than I, or j is root over of I, we can say that this loop will run root over of n times. So the time complexity will be n to the power root over of n, where n is the input, where n is the length of input that we have to check through. So the time complexity is n to the power of n, and the primes, it is also dependent on n, so the space complexity is also O of n. So it increases with the input element's size. So this is our code for 11th. Now let us check number 14th. The sign of product. Now we are here given a question. Write a JavaScript function sign of product that takes an array of integers as input. Okay. It takes an array of integers, and if the product is positive, we have to return 1. If it is negative, we have to return -1. If the product is 0, 0. But we have not to compute the product. So we do not have to compute the product, but we have to return if it is positive, negative, or 0. Now we can do this in this way. For the first thing is, what we have to do is, the initial thought that comes to me is, first we have to traverse through the array and we have to keep a track if there is a 0, because we know that if it has to be a product and if there is a single 0, then the whole array will be 0. So we will have to go through each and every element. We have to iterate through these elements and check if there is a 0, then it is the whole product will be 0. Now, apart from that, for the positive and negative, we have to keep a count of it. If we count, let us take a count variable and let us iterate through the array. And what we will do is, if we count how many positives or negatives are there in this array, we can determine if there, let us say we are counting the negatives, and let us say we count there is only one negative. So if there is only one negative, the product will obviously be negative. If the number of negatives is odd, it will definitely be negative. But if the number of negatives is actually even, then the whole array will be positive. So we can determine the number of counts. So here we are counting if what are we counting? Yes, if there are negative numbers. So we have a count variable here which we have initialized to 0. Now we are iterating through. We are using a for of loop instead of a traditional for loop, and we are checking for the edge case. That is, if there is a 0 in the array, then the whole product will be 0. So we are checking for a 0, and if it is, we will return a 0. But if it is not, if there is a negative number, we increase the count. Finally, what we're doing is, we are checking if the count is even or not. If the count is not even, then the product will definitely be negative. But if the count is positive, I mean even, the product will be positive. So this is the code for this challenge that we were asked to write. And here, what are we doing here? We are just iterating once. So the time complexity is O of n. If the nums array increases, we are just looping through it. We are O of n. We are not using any extra space here. We are not using an extra space except for the count variable, and which is negligent in the memory space. So the space complexity is O of n constant, but the time complexity is O of n. So for one final thing, let us do this one. The shortest word distance. Now we are given an array words ticked, and in this array we have to find the shortest position between the two words that will be given to us. Okay, so in order to calculate it, we have to track. Now since there will be these words will be more than once, as it is given here, so these will be more than once. So we have to keep a track of the distance between them. So initially, a brute force method that we can think of is we can calculate the first index and the last index of it, or we have to count the indices of the occurrences. Let us say we have coding and makes. We have 2 times here makes, and coding is 1 time, so it is in 0, 1, 2, 3. So coding is in the third index and makes is in the first index and first, second, third, fourth index. So we have to calculate 3 minus 1, and we have to calculate 3 minus 4. So a brute force solution would be to keep a track of all the indices of these words and then subtract and then check for the minimum and return. Now we are using an optimized approach here. Firstly, we are assuming that the word is not in the array. So we are using -1 for the word that we receive. This is the index which is not found. So we are initializing with the first word's index as -1 and the second word's the first occurrence as -1, and the minimum distance we are initializing to infinity, and then we are iterating through it. Now this is a single pass solution pattern, so we will solve it in a single pass. So we are iterating through through the words dictionary array, and we are iterating through it once, and we are finding the first occurrence of the first word. And if we have found the index of the word 1, then we are reassigning the index of the first word to I if we have found it in the ith index. And similarly, we'll search for this second word if it is available. Now, since both the words cannot be found in the same index, so what will happen is after this code block is run, we will check for it. Now, since it will fail, we will go to this block. Now, this block is the most important. Now, what we have done here is we are saying that when both the words indices have been found, only then we will calculate the distance, because in the first pass we have only found the index for 1, let's assume, but we have not found the second one. So this code block will fail because we are using an AND operator to check. Now I word is found, the first word's index is found, but this is not found, so this condition will fail. So we will go to the second iteration. Now when the indices for both these words will be found, it will calculate the distance. Now let us say we have found here the index for coding is 3, 0, 1, 2, 3, and makes is 0, 1. Now let us say for this is 3 and 1. Now the indices are not -1, so this will be 3 and this will be 1. And what we will do is math.min distance was originally infinity, and math.absolute we are using because when we subtract 1 minus 3, we do not want to use minus negative values. In that case, the minimum will be that negative value instead of the true negative value. So we are using math.absolute, and then when we are subtracting the distance, we will check whether infinity is smaller or 3 minus 1, 2 is smaller. Since 2 is smaller, we are updating the minimum distance. Then after going through all the occurrences, when we are finding all the occurrences, we have another occurrence here which is 3 for the 3 index for the first word and 4 index for the fourth one. When we will find 3 and 4, when it reaches the last index, then we have this index. This index was already calculated. The second word, which is 4, we have found a new index. So we will update the I word 2 to 4, and this is 3 already. Now we are checking through this loop. We have both the indices. We will check for the minimum distance. Previously was 2, and now we have 3 minus 4, 1. The minimum between these two is 1 now. Now we are updating it. We have reached the end of the array and we exit from it. Now, another important thing is, suppose somebody enters an input which is not at all in the array. In that case, we are actually handling an edge case here. In that case, we cannot return infinity, because in that case it would be infinity, because this will never run, because the index was never found. And if we just return only the minimum distance, it will return infinity, which is wrong. So what we are doing is, if the words that we are given as parameters are not found at all, then we are checking if the number is finite. We are using a method from the number dot is finite. We are checking if it is finite. If it is infinity, we will return invalid words. Now we are using an if-else expression. So this is a shortened expression. Now if we have found a valid distance, only then we will return it, else we will output invalid words. So this is an edge case that we are handling. Now let us look at the time complexity. Now we are iterating through this array only once. This is a single pass solution. We see that these are not nested arrays, nested loops. We are just checking it in a single pass, and we are checking for it only once in one iteration. So what we have is a O of n, a big O of n for the time complexity. And for the space, we actually have not used any significant space, since we are just returning minimum distance, which is just this variable. So the space is also O of 1. The last one, insert 7. Okay. So we are given a string consisting of characters including spaces, and our task is to insert character 7 immediately after a set of 6 characters. So we are here given a string, and immediately after every 6 characters, in the 7th character we have to insert the letter 7, and we have to ignore spaces. So the first thing that we can think of is splitting this sentence. Now, in order to split this sentence, we can do one thing is, we can iterate through each of this instead of splitting. Well, instead of splitting it into an array, what we can do is, we can traverse through the characters as they are. We can also iterate over strings using the for of loop. And while using the for of loop, we can iterate over the characters. We have the characters, not just their indices. So when we have that, we do not have to convert it into an array anymore. So I will iterate through this string, and I will keep a count of characters 1, 2, 3, 4, 5, excluding this space 6 and 7. So what we have to do is, we have to skip when there are spaces. Now since we are iterating through this and we have to skip, we need a variable count, and then when we have reached the 7th character, we insert it 7. Now we do so by, firstly we create a result string where we will return the result, and we are tracking our count here, and then we are iterating through this, and if we find an empty space, if we encounter an empty space, then we are passing outside, we are skipping it. If it is not an empty space, we are calculating the count and we are skipping over empty spaces, and then what we are doing is, we are adding up the characters as well. We're adding up the characters one by one. We are just duplicating the string that is given to us, but what we are doing is a simple modification. If we have reached the 7th element, since we have started from 0, the seventh element would be index 6. So if the count has reached 6, what we will do is the result string, we will add 7 to that character. And then we will reset our count to 0 again, so that we can start our count from here again. When we have reached this element, the count is 0, then 1, 2, 3, 4, skip 5, 6, 7. So we have to insert a 7 there. So what we are doing is we are inserting a 7th after every 6 characters again, and we already were counting it, and here we are setting the count to 0 again, resetting it. So this is the end of this solution. So now we have walked through the 5 questions, I think more than 5, which was required to be explained. Thank you.